All right, so this is going to be a video all about complex numbers. Now, before we can really understand complex numbers, we need to review what real numbers are and then go over what imaginary numbers are, because complex numbers are essentially just a real number mixed with an imaginary number. So we need to go over those two kinds of numbers first. Okay, for the first one, I mentioned real numbers. These types of numbers you should already be familiar with. Real numbers deal with integers. Integers are just going to be negative whole numbers, positive whole numbers, and zero. Okay, and it does have to be whole numbers, so I'm going to write that in there. Positive whole numbers, negative whole numbers. Okay, so we have integers. We also have rational numbers. Okay, rational, the key word here is this ratio part of it right here. Ratio being the key word in here. A rational number is just when you can express a certain value with an integer over an integer. So we have a over b right here. Just imagine that a is an integer and b is also an integer. So you can make a ratio out of two integers. That's a rational number. Now, if you cannot do that, then it's considered an irrational number if it's still real. Okay, irrational numbers, a good example is like pi, or like the square root of 2. They have non-repeating, non-terminating decimals, where rationals, they can either have a repeating decimal or they actually can terminate. So an example of that is like if you had 0.3 repeating, that's technically 1 over 3, so that's a rational number. You can have something like 0.5, which is 1 over 2. It's terminating, it stops. The 0.3 goes forever, but it repeats. Where pi does not repeat a certain pattern, square root of 2 does not repeat a certain pattern, so that would be considered irrational. You cannot make it a ratio of two integers, essentially, for that. All right, so that's something you should already know. So what we're going to do is we're going to compare this to imaginary numbers. Now, if you remember what I said before, a complex number is just an imaginary number with a real number component as well. So it's a number that has two components, a real component and an imaginary component. So you do have to understand both of these to understand complex numbers. So an imaginary number is essentially any number. I'm gonna write this down, but I want to kind of say it first. It's any number that if you square it, you actually get a negative answer. Okay, so it's any number where if you square that number, you end up with a negative answer. So I'm going to write any number squared that yields or produces a negative number. Okay, and I should say a negative real number. Okay, now that is kind of weird to think about, so let's kind of break this down a little bit. Any number squared that yields a negative real number. So if we just had some number, let's just say 1, we'll just start off really easy for the example. If we did 1 times 1, you end up with a positive number. Okay, if you did negative 1 times negative 1, you end up also with a positive number, because a positive times a positive is positive, a negative times a negative is positive. So how can you multiply two numbers? Let's just say it's going to be I for imaginary. So these two numbers, you're multiplying it by itself, and somehow you end up with a negative answer. Let's just say negative 1 here in this case. Okay, how is that possible where you multiply two numbers and you end up with a negative? Well, it's not possible using real numbers. That's kind of why imaginary numbers were actually created, was so you can actually do something that is ordinarily impossible. So it basically defines what imaginary numbers are based on this impossible thing that we couldn't do before. So they just made up a new set of numbers that can actually have this property. So if we kept continuing with this, we have I squared is equal to negative 1. Now this I squared equals negative 1 defines what I is. I is considered an imaginary number unit. So this is going to be, I'm just going to write imaginary number unit. Okay, this unit, this I, is going to be the factor of any imaginary number that you see. Okay, for example, if you had something like, I don't know, 2i, okay, that's an imaginary number. If you had something like 3i, that's an imaginary number. If you had something like 1.59i, that's still an imaginary number. 4i over 5, or even 3 over 2i. Although this is not a simplified example of an imaginary number, but we're going to go over that later on in this section. But these examples right here that I just drew out, here, I'll just circle them here. All of these right here are all examples of imaginary numbers because they have that imaginary number unit in it, which is I. Okay, in a way you can kind of think of it like a real number multiplied by 1 is itself. That 1 is the real number unit. Okay, the I is the imaginary number unit. Okay, every real number has a factor of 1 in it. Okay, every imaginary number has a factor of I, essentially. So if it has an I in it, then it's an imaginary number. Okay, so that's essentially how that works. Now going back to this concept right here where it's I squared is equal to -1, another way that you can define what I is by saying I is equal to the square root of -1. You do have to make sure you understand this. I'm going to highlight this as well. You do have to understand this because this is one of the major concepts that you're going to need to be able to solve imaginary number problems, is to understand that I is equal to the square root of -1, which you can't do the square root of -1. If you tried it on your calculator, it would yell at you. But if you invent imaginary numbers to be some type of number that you can do the square root of a negative, then you actually end up having what an imaginary number is. Okay, so that's a breakdown of what real numbers and imaginary numbers are. Now we're going to go over what complex numbers are. Okay, so a complex number has the form of A plus B times I. Now, if you remember before, I said complex numbers are any number that has a real number part and an imaginary number part. So if you notice right here, we have A and B, and I'm just going to tell you right here that A and B, so it's right here, A and B are real numbers. So if A is a real number, then you have the real number part, and then B is a real number times an imaginary number. That means this part right here is the imaginary part, and this part right here is the real part. Okay, so we have the real and the imaginary, and that's kind of why it's called a complex number. It's not a complex number because this is some complex, complicated concept. It's actually called complex because what a complex is when you combine a bunch of things together. Examples of that you've probably heard of, if you've ever heard of like something called like an apartment complex, it's usually a bunch of apartments combined together. That's essentially what complex numbers are. It's an imaginary number and a real number components combined together. You might have heard of the military complex. It's a bringing together of a bunch of things related to the military. So anytime you see the word complex, don't think complicated, think bringing things together like a real number and an imaginary number. Then you kind of understand what a complex number is. So an example of this would be like something like 1 minus I. Okay, it's got a real number component and an imaginary component. Another good example is 3 minus 9i, or you can even go irrational with this, the square root of 2 minus pi I. Now, A and B are any real number, including 0. So if A was equal to 0 and B was equal to 0, then you would end up having 0 plus 0i, which 0 times anything is 0. Okay, believe it or not, this is still a complex number, even though you might be thinking, wait, there's no imaginary number part. There actually is, it's just multiplied by 0. So a way of thinking about this is every real number is a complex number and every imaginary number is a complex number, which is kind of crazy to think about because every real number that we've gone over before, integers, rational numbers, irrational numbers, those are all complex numbers. So believe it or not, you've been working with complex numbers this entire time that you've been doing math. We just didn't really need to worry about that I part. So it was a complex number without any imaginary part, or the imaginary part, the B is equal to 0. But A and B could be equal to 0. And so that means any imaginary number is a complex number, any real number is a complex number. They both kind of fit in with that. Now to kind of show you what this means, if I drew a Venn diagram. So to kind of explain this a little bit better, I'm actually going to draw a little Venn diagram that might help. So we have complex numbers, and complex numbers, like I said before, are made up of a real number component as well as an imaginary component. Okay, and if you remember what we went over before, real numbers are also, examples of them is integers. We have rational numbers, and then we have irrational numbers as well. Okay, now those are their own little island here. So I'm going to kind of put a circle around here. Okay, an integer, a rational number, irrational, those are all considered reals. But if you remember what I said before, all real numbers are technically complex numbers as well. So I'm going to include that over here in this circle for complex. So anything within that, and I try to color code this too, but anything within that green is a complex number. So all these real numbers are also complex numbers. All the imaginary are as well. But this imaginary needs its own little circle as well, because a rational number is not considered an imaginary number. Okay, so that's why it's in its own little circle. So anything that's in the green circle is complex, which is any real number and any imaginary number. Anything that's real is within this right here with integers, rational numbers, irrational numbers, and then we have imaginary right here, which is its own separate island. So hopefully this Venn diagram helps with the concept of what a complex number is. So this video is basically just an intro to complex numbers. If you have any questions about anything in this video, let me know.